This is a 3D printer. It takes three-dimensional models saved on your computer and physically creates them right before your eyes. Let's take a closer look at the A1. This part is called the gantry. Your 3D object will be printed on a metallic build plate. This can be removed so that it can be washed or even replaced with a different one. It's held on by strong magnets directly underneath. There is a touchscreen right here to control the 3D printer, but you can also control it from another device such as a desktop computer or even your mobile phone. At the top of the machine, there is a plastic support arm that holds the filament spool. The end of the filament is hand-fed into the tube opening shown here, then through the plastic tube, which connects all the way down to the tool head. Inside, the filament will be melted and come out the very bottom. Inside the tool head, there is a stepper motor, which will spin to pull the filament through to where it is melted. There is another stepper motor over here. When this spins, it moves the belt that goes all the way across here. Moving the belt causes the tool head to move left and right. This bar is called the X-axis linear rail. There are two threaded rods on each side. You can actually see them if you move in far enough. When these spin, the rail and the tool head move up or down. They call these the Z-axis linear rails. This means the tool head can only move in 2 dimensions, but this is a 3-dimensional printer. For the 3rd dimension, the build plate moves back and forth on the Y-axis. Down below, there is another stepper motor that spins another belt. This is what moves the build plate back and forth. 3 dimensions of movement allows the printer to create your 3D models layer by layer. There is a camera up here to take images of the objects as they are built. You can even make a time-lapse video, which is really fun to watch afterwards. 3D printing can be as short as just a few minutes, or as long as several hours or even a day or two if your object is complex enough. The area inside of this imaginary box, this is called the build volume. You can only create 3D objects that fit inside of the build volume. If you want to print something bigger or maybe more complex with more integrated parts, you can still do that. You just have to find a way to print it in several different pieces. Your 3D object will probably be in one of these formats. Then you take that and run it through a program called a slicer. This takes your 3D model and splits it into many distinct layers that can be 3D printed. The slicer uses this and produces something called G-code. This is the step-by-step instructions for how the 3D printer should create your 3D object. These are very specific instructions on how to move the stepper motors. This controls where the tool head and build plate moves, as well as when the filament comes out. Fortunately for us, you don't need to understand this G-code. You just need to send it over to the printer and it does the rest. So let's walk through an example and see this in action. Once you press the print button, the build plate starts warming up, as well as the hot end of the nozzle. Inside of the tool head, the stepper motor starts to spin, which pulls the filament through. The part at the bottom, this is called the nozzle. It's the piece that gets really hot. If you're using PLA, one of the most common types of filament, it will heat up to 220 degrees Celsius. Even with the protective cover, you definitely don't want your hands to get near this during the printing process. At this point, the tool head will come over to the left side and begin to purge some of the filament to make sure that it's flowing. This is called purge filament, or informally known as printer poop. Yes, the printer has got to put it somewhere. Many people will actually 3D print a special container to catch all of this purged filament. Now that the filament is flowing, the 3D printer will take additional steps to prepare for printing. One of them is called bed leveling. This is making sure that the build plate is completely level. Any offset could mean flaws in the 3D print. Bed leveling usually takes at least a few minutes. Modern 3D printers make bed leveling automatic, much easier than previous generations of 3D printers. Right before it actually starts printing, it usually draws a few lines at the front to make sure it's still flowing correctly. At the back of the build plate is the nozzle wiper. Make sure the hot end is nice and clean. And after all of that, we are finally ready to start printing. The first layer is extra important because it has to stick really well. This is why the build plate is heated. The build plate is usually textured to help it stick a little better, but sometimes a special glue is used. Oftentimes, the printer will draw the outline of the layer first and then the inside. This inside part is called the infill. You could make this part completely solid, but that would be a waste of filament. It's common to do about 15% infill, just enough to give it structure on the inside so that it maintains its shape. When it's done printing, keep in mind that the build plate will be hot, so use caution, but you should be able to grab your new item within a few minutes. It cools pretty quick. Let's take a look at this 3D model. When printing the overhanging portion of this model, it would be necessary to print into thin air, which is not possible. For something like this to print correctly, it needs to have supports added. It's the green tree-like structure that you see here. You'll notice that the 3D printer does okay with some overhang, but once it gets to the top, we need those supports. When it's done printing, the supports can be broken off. Look at that, 3D printed gateway arch. There was a time when you could only print 3D objects in one color, but the A1 3D printer has the ability to print in several different colors. For this to work, you need a separate device called the AMS Lite. That stands for Automatic Material System. This connects directly to the A1 printer. You have room for 4 different filament spools. And then there are 4 clear plastic tubes that connect the AMS Lite to the A1 printer. This is called the filament hub. The end of each filament spool is fed into the holes inside the AMS Lite, and a motor starts pulling it through the tube. Filament spools from Bamboo Lab have an RFID chip. Using this, the machine automatically knows the type and color of filament. Very convenient, so you don't have to manually enter this. When it starts preparing to print, the AMS Lite will push the first filament through and the melting process begins. The 3D printer will warm up and calibrate just like we've seen before. When that's done, we're ready to start our 3D print. At some point, the printer gets to a place where it needs to switch colors. The tool head moves over to the side. It will press this lever against this piece sticking out here. Inside the tool head, you can see that pressing the lever cuts the filament. The filament is now retracted up until about here. Then the second color is pushed into place. Notice how we still have a bit of old filament inside of the nozzle. We can't start printing until we get rid of this. The tool head moves over to the other side to get rid of this extra filament. Let's take a closer look at what happens on this side. We have a small lever here. When this lever is pressed, it moves the sweep. The tool head moves over and presses this lever. Then the purged filament comes out. It has to do this long enough to completely get rid of the old color. When the tool head moves back, the sweep will get rid of the purged filament. Now the printer is ready to continue with the next color. The A1 is an entry-level 3D printer. You can do a lot with it, but there are some downsides. It's informally known as a bed slinger. This is because the build plate actually moves back and forth. This means you'll need to plan for a little more counter space. And the rapid moving back and forth can sometimes be a problem when you start printing out larger 3D models. It's also 3D printing out in the open. There's no walls enclosing this area. That makes it impossible to control the temperature and humidity during the printing process. Let's take a look at one of the more upgraded 3D printers that solves some of these issues, the X1 Carbon, also made by Bamboo Lab. A more expensive model, but there are many advantages to this. The first thing is that it's fully enclosed to control the climate inside. There is a glass panel on top and a glass door in the front to access the inside. Up at the very top is the tool head. It can handle higher temperatures, giving you finer control over the materials and quality of the final print. The X1 Carbon is referred to as a Core XY. The tool head does the moving on the X and Y axes, and the build plate moves up and down on the Z axis. Compare that to the A1 bed slinger that we saw earlier, rapidly moving the build plate back and forth. The X1 Carbon provides a lot more stability, rapidly moving the tool head, but slowly moving the build plate up and down as 3D objects are printed. The X1 Carbon has 3 threaded rods. When these spin, it moves the build plate up or down. The X1 Carbon uses something called LiDAR, which will scan the first layer to check for any problems. On the side, there is an improved camera that will monitor the rest of the printing process and take time-lapse videos. It is a bit darker inside just because it's enclosed, but the chamber LED light makes it so you can see a little better. Here's the fan to better control the temperature and filter the air in the chamber. On top, you can usually put your AMS to print in multiple colors. Notice on the A1 printer we had the AMS Lite, but this one is just called the AMS. It has a lid to fully enclose your filament spools. This keeps out the moisture, allowing for a higher quality of 3D prints. The future of 3D printing has never looked brighter.